In this video, we'll discuss the importance of application layer. In brief, we will discuss the overall aspects involved in the design principle of an application layer. As we have seen the 5 layers in sequence, how they are all stacked, starting from the application layer down to it is the transport layer, then network layer, data link layer, and physical layer. Every layer has its own importance. Every layer works on certain principles and provides certain services to the above layer. Now, when it comes to the application layer is that layer which provides an access to the infrastructure to users. Because above applications, there are users who uses the applications. And applications at the application layers are not only in isolation, they also use certain protocols on the application layers. So as a designer, when you design certain applications, so you make good use of certain protocol which operates at the application layer. Whenever you design any application, that application abstract the whole infrastructure and provide it to the user. So user has not to worry about what infrastructure his or her application is using in the background. So application layer provides an easy means to access the network infrastructure and instructor because when you design the application, those applications are distributed in nature because your application you have designed in such a way that it is running on different end systems, and when it is running on different end systems, they have to exchange messages for proper communication and execution of both the processes on those end systems. So how that exchange will happen, that exchange of the messages on those two end systems which are running the application, same application via or through network infrastructure. This is one important thing. So as a designer, you have to think for a distributed application. Then you have to come up with the whole bunch of message communication, how you will ensure that message communication, that communication will happen through network. Then we will understand the evolution of application over a period of uh, initially in 17 and 80s when network internet came into existence. At that time, user base was limited. Only some researchers were involved, scientists, academicians, students in the universities. Only they were the part of the network. So at that time, based on their requirement, they came up with the applications which was using the infrastructure for some limited purpose. Either they were using it for emailing and remote computer access, and third one maybe for data transfer, file transfer operations. So that was primarily more data centric. So those classical data applications were into existence. But over a period of time, when an infrastructure companies started to invest, they want to monetize their investment in infrastructure, because initially in 70s and 80s it was all research driven, so public fundings were more, but when private funding got started into this, then they want to monetize it, so they were looking for some killer application so that it may be attractive. The infrastructure and the applications which you will run over it would be attractive to the common people. So they came up with the first killer application was World Wide Web. Through World Wide Web, you can maintain your servers all across the world, and from other locations you could surf. So web surfing was common. Then comes the search engines. Not only you can maintain, you can search. If you don't know any information, you can search over a web. It will uh, point to that server which maintains that information. So that service then brings a whole lot of change. And then comes the e-commerce website. So it completely change the course of activities over a period of time, how business were used to operate. Uh, they have moved over the internet and they use it as a platform for reaching out to more people. And over a period of time now, you can see there are a whole bunch of applications which are bandwidth centric, because over a period of time there is a change on network access side also. So the technology changed over a period of time and started providing more bandwidth to access the network infrastructure. I'm talking about the residential access network. Initially, those networks were not designed for bandwidth-centric applications, but over a period of time, because as the business grows, as the user requirements becomes more, as the user requirement in terms of running applications which require more bandwidth grows over a period of time, so the access technology also grows and started providing more bandwidth to the user to access the network infrastructure. And then there comes a whole lot of multimedia applications which deals in video streaming, live videos, and audio, IP, telecom, and real-time applications. I'm talking about real-time applications, real-time gaming. So all these are bandwidth intensive applications where you require more bandwidth, and the delay should be less, because these are all interactive applications. So this is regarding the evolution of applications over a period of time. Now, so here in this module related to application layer, we'll initially discuss the conceptual implementation aspects of network. Uh, we will look at this topic in regards to the transport layer services provided to the application layer. What are all the transport layer services which application layer seeks from it? And there are two paradigms which we will say, which we will discuss, based on which application are designed. One is the client server architecture, and another one is peer-to-peer architecture. Both we will discuss. But primarily the focus across the chapter in future would be on the client server architecture, because all these protocols, HTTP, FTP, mail transfer protocol, post office protocol, internet mail access protocol, and DNS, all are based on the client server architecture. And then towards the end, based both on TCP and UDP, will understand the application designing through socket programming. So we'll understand socket API, we will use C socket based API. Uh, so straightway, these are the network applications. Already I have discussed about the network application evolution over a period of time. Here also you can see the network application. So uh, you can divide the network applications based on if certain user applications may require more bandwidth, some so those require more bandwidth, those are strict to their bandwidth requirement, and some are elastic in their bandwidth requirement, so they hardly bother about whether uh, the bandwidth is more or less, they can somehow adjust to it. And some have a constraint regarding delay, some have a constraint regarding jitter, some have constraint as I have already disclosed, some have constraint regarding the overall throughput. So based on the user requirement, then you have to tweak your protocol either at the application layer, or you have to make good choices, the protocol which you will use down the stack, starting from the transport layer till the physical layer. So as a designer, what exactly you will do at the application layer. So that is the first thing, that as a designer, as an application layer designer, what exactly will you do? So obviously you have to, because as I have already disclosed, both application layer and transport layer, both are software based. So here also you will write a software, you will write a program for running that application. So, but the change is on a single system, when you write any desktop application. So anything which runs over a single operating system. So operating system, when your application you run, it also require to communicate with other process. That is called inter-process communication. But that is generally being handled by the same host operating system over which your application is running. But here the situation is different, little bit different, because you are designing and creating a distributed application where some part of your application you will run on one system, maybe your host operating system may be A, some part of the same application you are running on some different host which may be hosting some other operating system, and so there is a clear mismatch when you have to communicate. Till now, we were designing applications which were running on a same host operating system. So the inter-process communication was easier there. But here, when one process you are running on one end, another process you are running on another end, and both processes are being hosted by different operating systems. So how you will ensure the communication? So that's where you require certain API which both host operating system can understand, and who will provide you the inter-process communication infrastructure. Network will provide you the inter-process infrastructure here. So whenever one end system process required to communicate with another end system process, then that you will create a one end system will create a message, and that message will pass through the network infrastructure and will reach the destination node. Destination role will process it, and if it has to once again communicate back with the process which started the communication, then both will engage into communication, and that facilitates through network infrastructure. So that's what we want to design. With example, now we will understand, like if there is a web server and there is a web client that is called the web browser, you have to engage into communication with certain servers. From there you have to look for a website. So you are digging into website and you want to engage with that web server. So what initially you will do, you will run a process, you will run your this desktop application, that is web browser. So that is we are considering as one process you're running on one system, and there is one up running process somewhere across the globe that is maintaining that website through that web server that is always up running. And then you are running your process here on one system, another one is already on some other system, then you have to start communicating, because now you require certain web object which you want to look at your desktop. So you will make a request. So your on behalf of your process which you have run, that is web browser, that client side program will ask for information. So you will create a message, that message will go, that message incorporate the information that I'm seeking these information. Then web server in return will process it and will send you the web object which you are seeking. Then your client side, means your client web browser, is equipped in handling that received message. That received message may be in HTML along with CSS. So it may be in any form, JavaScript. So in any form, your web client is already equipped in handling any format, and that format it will reprocess it and will put it in front of you. So that's how you run. It is a crude example. There are sophisticated applications. So as a designer, your job is in finding out the ways how you will communicate with the other part of the program. So if we will see the web, so web involves two parts. There is a client part and there is a server part. And how that communication will go on, which protocol at the application layer will you use. So here in the web, we will use the protocol HTTP protocol, which will ensure the protocol, as I have already discussed. What is the role of protocol? The role of protocol is in defining the message format which you will send, what goes into the message, so that both the parties can understand it. In what order will you actually exchange the messages? Whenever you will receive one part of a message, how will you respond? So what goes into the request message, what goes into the response message, how that engagement will happen, that is all the part of protocol design. And as an application designer, you have to use the underlying protocol, and over that protocol you will design your messages, you will design the sequences in which that operation will take place. So that all goes into the creation of network application over the application layer, at the application layer, using the application layer generic protocols like HTTP, file transfer protocol, DNS protocols, all these things. Whenever you will write a program, it's in addition I'm explaining it, whenever you will write a program, your program will be only on end systems. You're going to run it only on end systems. So the protocols which you have designed, application layer protocol and transport layer protocol, and over the application layer protocol you will design your own application which will be used by users. So all these things you are running only on end systems. Apart from that, network layer, data link layer, and physical layer, all intermediates will also run these type of protocols. So whenever you design an application, so you are designing it only for end systems. So considering the end systems hardware, you have to design it, hardware and software, which or whatever the operating system they will use. So based on that resources which are available on the end systems, you have to design your protocol. Though obviously while designing your protocol, sometimes you have to tweak your protocol considering the network infrastructure also, that what kind of bandwidth your network is providing. So if we are in the generation where the bandwidth is a constraint, your networks are not providing the bandwidth, so obviously you will not come up with an application which is bandwidth intensive. Over a period of time, your network grows and now it is supporting bandwidth. Now it is supporting less delay sensitive protocols, delay constraint applications also it can support. Then as an application designer, you can think of designing protocols at the application layer which are bandwidth hungry, which require less delay, so which are delay constraints. So in that way also, with generations over a period of time, you can think of designing your applications. But primarily, whatever you will design, that will run only on the AND systems. So these are not going to run on the routers which are in place as an infrastructure. On the routers, only the protocols till the network layer will be run, because a router is a mix of both software and hardware. You require some part of the hardware, but you also require routing algorithm to run over that hardware. So you require certain routers operating system which can manage the router hardware also. But as a network application designer, your job is not to touch that part of the software. Your job is just restricted till the application layer, which whatever you will write will be run only on the end systems. So here you can see, if these two devices, one in the mobile access network, another in the same institute, want to access there somewhere, we are maintaining the server. So the communication is in between the application to application layer. So these both application code will run only on the AND systems. Now we will understand the application architectures, that as a designer, when you have to design, what sort of application architectures are there to use. Because as a designer, you have to come up with an architecture in which you will set up your whole code, you will segregate your code. So there are three architectures in total. Third one is the hybrid one. First one is the client server architecture, that you will segregate your code in such a way that some part of it is a client part and some part is a server part. All the architecture supports the distributed applications. When you have to design a distributed applications, all three architectures will support the distributed application design principles. The first one is the client server architecture, in which some part is the client and another part is the server. So you can understand it through web browser and web servers. So one part of the system should be the client, which will initiate the communication, which will seek certain information from the servers maintaining over there, and then the communication will start. So that is the client server architecture. Very simple, very crude, because it's a sort of a centralized mechanism. Servers you can consider as a central thing, and all other clients across the globe can connect to that central authority for exchanging information, for retrieving information, for putting information on it. So you can use server for any reason. You could have the web server, you could have a data server, you could have some cloud server, any service if you are providing, you can maintain that server. So servers are central in its architecture. Here for client server architecture, servers are central, which maintain certain type of a service. If as an individual you want to provide any service to your user base, then you will come up with one server which will provide that sort of service. So suppose if you want to maintain any you want to give any data service to your client, so you will maintain one data server, then you will allow all other clients uh, for accessing that information. So all servers come up with certain service which other clients can use. So while designing the application, you have to come up with one client side application and another one is a server side application, and they both should use the same underlying application layer protocol, so both can understand each other's communication, the messages which they are exchanging. That is called the client server. When it The problem with the client server is that First is it is central. So obviously, when it is central, then it may break also, because the bottleneck is the central server. It is not scalable. If you have to scale it, if you have to engage more audience, if you have to increase your user base, you have to increase your server counts also. You have to farm different servers. So in that situation, it is costly affair. So in contrast to this, so to solve this problem where you want to resolve this issue, you make it because here, though you are using the distributed application, but somewhere in the design principle still it is central, because servers are doing uh, more. Servers are central to this client server architecture. So though in design principle it is distributed, but in certain sense still it is centralized in other sense. So if you have to completely distribute, though the distributed application also you have to distribute all across the globe, then comes the architecture peer-to-peer. Here there is no concept of client and server. One who is right now working as a client can also act as a server afterwards. So we will take an example of a file transfer. So if they have to share the file among themselves, so then they all will group together, all peers will group together, and then they will look for the node which has the data. Then the other node will start downloading the data. The moment you are downloading the data, others will come in contact with you and will seek the data. So at that time, you will then start uploading the data also over the internet, so that they can also start downloading it. So both at the same time you are downloading it, at the same time you are uploading it also. So when you are downloading, you are client; when you are uploading, you are server. So there is no complete contrast or division that what is client and what is server based on requirement, based on the time configuration, what operations you are doing. Uh, you are acting sometime as a client, sometime you are acting as a server. Then there comes a hybrid architecture in which we will make good use of both the architecture, because in peer-to-peer, in client-server architecture, it is a simple architecture. It is simple to maintain. Whereas in peer-to-peer architecture, it is not so simple. Managing peer-to-peer architecture is difficult because it is highly distributed. In true sense, it is distributed. Though client server is using the distributed applications, but it is still centralized. The servers are centralized. You can maintain server. You have a good control over the servers. Though you have no control over the client, but still you have good control over the server. But in peer-to-peer application, both client and server, you don't have a control. You don't have a control over the services which you are providing. So it is difficult to manage peer-to-peer architecture. Whereas if we want to make good use of both the client server and peer-to-peer architecture, then comes the hybrid architecture. With example, you will understand like instant messaging. If we are using WhatsApp. So if you are using WhatsApp, then what happens? So there is a WhatsApp server running. So whenever we go online, whenever we open our WhatsApp, whenever we run that application initially register our IP address to the WhatsApp server. And whenever we want to communicate with one of our peer in the buddy list, whenever we want to communicate, initially our application will seek the address of the IP address of that individual from the server. And that individual is also doing the same. Whenever he is going up, running that WhatsApp application, he is also registering his live IP address, current IP address. And so that IP and that WhatsApp server is doing what? It is just registering the current IP address concerning the devices. So whenever from one device to the next device you want to communicate, initially you will seek the IP address of the peer where you want to send the message, and then whenever onwards this you will start communication, that communication will be peer to peer. That is called the hybrid of client server and peer to peer architecture. So here you can see the client server architecture. Uh, it is central in nature, so it is running the distributed application. One part of the application is on one end, another part is on the another end. With example, if you want to understand like web application, so one part of the client is called web browser. Web browser is on your system, and someone is maintaining a server. So here this institute is maintaining a server, and from here, this is the mobile access network. This is the network core. We are using the same diagram for understanding it. So this is the residential complex. So from here, so these are all the clients which are accessing the server application here. So client application and server applications are in tune. They are in message exchange. They are in communication. For retrieving, this client want to access their website. This client also want to access their website. This client also wants to search something. So now, when this is the requirement, so how will you deal with it? Because at any point in time, these clients can retrieve information, can want to communicate with you. So you have to always keep your servers on. You have to always run your applications active on these servers. That is first thing. Second thing is that because these clients are all across the globe, if you will keep changing your IP address, then you have to communicate your IP address all across the globe. That adds to the cost, which you don't want. So in that situation, always whenever you maintain a server, you always prefer that you maintain a static IP. You might have heard about the static IPs. So whoever maintains the server, they always seek uh, static IPs. They always maintain static IPs, and then they register their static IPs with the global DNS servers. So and they hardly change it, because if they will change, they have to re-register it, which they definitely don't want to do that. In rarest of the rare case, if they have to do it, if they are placing their server from one physical location, geolocation, to another geolocation, they eventually have to do that, but still they want to keep that IP address if it is possible. So that is one thing, because they don't want to register their IP address again and again. That is another thing. And if you have to scale your operations like Google search, uh, that is one application. So initially, if they would have come up with one server because the requests were less, but over a period of time, when the user base increased, everyone wants to search. So definitely one of their server would not be able to handle, because that doesn't have that much capacity in terms of resources. The resources are not available which can handle so large user base. So in that situation, they have to scale it up. For scaling it up, what they usually do, they maintain different servers all across the globe, and then they abstract. That is called the data centers. So in the data centers, there may be thousands of servers running up doing the same operations. So I'm just talking about one application, that is a search. So regarding the search, there are several servers running up in the Google data centers. Whenever you will try to contact them, one of the controller there will actually assign your query to one of the server running up there in the same data centers, and they have several of the data centers all across the globe. What is the reason for that? Eventually, when we go ahead, we will understand that why they have different data centers all across the physical location, geolocations, because they want to reduce the response time whenever you inquire them. So because if from here you contact the data center which is all across the Atlantic Ocean, so it will take more time uh, for that data center server to respond to you, because the propagation delay will be more. and there may be some congestion also. So obviously, whenever you want to communicate with them, so DNS will give you the IP address of the nearest data center. And whenever you will reach out to the nearest data centers, they will assign. So there also there are several servers up running there. So then the controller there will assign your query to one of the server, and that server will then start communicating with you. So all these details are abstracted from you as a user. You are not worry about, so you are just worry about the DNS server. So DNS server will abstract all these things from you. DNS server will provide you only one IP address, and through that IP address you can contact the nearest data center instead of going to the far away data centers. And the client can change here in the client server architecture. Client can change their IP addresses whenever they want. They can come at any time. So the connections may be intermittent in nature. And but here the problem is that if both clients have to communicate, they can't communicate with each other. They can only communicate with central servers. So server to client communication is possible. Here, client to client communication is not possible. This is the pure P2P architecture. Already, as we have seen, that what is the requirement, because here, if you have to scale your network in the client server architecture, you have to invest more, as we have seen with the data centers and the data server farms. So there the investment goes in, but if we have to actually done away with that investment, what is the other solution? So this peer-to-peer architecture is mainly for those type of services which are bandwidth intensive, which require more bandwidth, like multimedia streaming, IP, TV. Uh, so these kind of applications which are bandwidth intensive, there if you will even invest more, how, because the user base is so much that how much can you invest? And if the business proportion would not be more, there's no point in even investment. So they come up with a solution with peer-to-peer architecture in which there is no clear demarcation in between client and server. One can act as a client to one time when it is seeking information from other. At that time, other who is providing that information, that is also the part of peer group, that will act as a server for this client. Whenever it has certain information and some nearby node want to access that information from that node, at that time it will also start acting as a server, and that node which sort of information from that this node would start acting as a client. So at a particular time, with respect to whether you are seeking information or downloading information from other tier, at that time you are client. Whenever you will start uploading any information and other one has sought that information from you, you will also act as the server. So one node at a time can act both as a client and server. So there is no clear demarcation. Here, there is no constraint that you have to maintain IP address permanently. You can change your IP address because you are normal peer, you are the normal node. The example is file sharing protocol called BitTorrent protocol. And so whenever you have to scale up, so it is highly scalable and it is self-configurable. So any node whenever joins, you have to just run a peer-to-peer application on your system, and the peer-to-peer application will do all these connections. And so the protocol is completely different. It is not so easy even to design the peer-to-peer protocols, the peer-to-peer applications. Whenever as a designer you design, these are difficult in designing in comparison to uh, the client and server, that distributed applications. But it comes handy when you have to deal with bandwidth or traffic intensive applications where you require to have to actually operate with those bandwidth intensive applications. is highly scalable but difficult to manage, as I have already explained. Now comes the hybrid architecture, where you will use some part of the client server and peer-to-peer. Already I have explained it using instant messaging. Skype also use the same architecture in which you maintain one server. So that server just register the IP address. So initially when you will run your desktop application, Skype desktop application, you are registering your IP address with the Skype main server, because you have to log in everything. So based on your login information, so the Skype server will maintain your IP address along with your Skype ID. And whenever any other one wants to communicate with you, that person will seek these information from the Skype server. Skype server will provide this information uh, to both the parties. So it will exchange individual's IP address. Then that peer-to-peer communication will start. Because initially both peers are not aware about their IP address, and until and unless they are not with the IP address, destination IP address, they will not be able to exchange messages with each other. So to resolve this problem, central server is there. So initially only once both the parties will use the central server in registering their IP addresses, and then that central server will exchange those IP addresses with each other. Once it is over, then both the parties can engage in their communication, and that will be peer to peer. Likewise, instant messaging I have already discussed with you in respect to WhatsApp. That's all. In the next video, we'll discuss about the process, communication, and socket.